Okay guys, today we're going to talk about evaluating limits at x approaching infinity. What's the answer of that and how are we going to do it? The basic thing in evaluating limits is by using tables. So I'm going to choose values as x approaching infinity. Let's start by 10, 1,000, million, and so on. So if you do direct substitution here, you will get 1 over 10, which is 0.1, 1 over 1,000, 0.001, 1 over a million, 0.5 zeros, then 1. So what's happening actually? As x approaching infinity, the function or the y values are approaching to, if you look at this, 0.1, 0.001, 0.00001, so that's actually approaching 0. So what does that mean? This means limit 1 over x as x approaching infinity, or if you use negative infinity, of course it will be the same thing. So as x approaching infinity or negative infinity, the answer will be equal to 0. So actually this is for positive or negative infinity. The answer is 0 when you divide a number by infinity. And this rule is very important and we're going to use it later. So let's try to evaluate this function. Well, maybe you will think that, am I going to use a table each time? Of course not. I'm going to teach you how to do this now algebraically, and then I'm going to show you how to do it with a shortcut. Okay. As you notice here, the highest power of this function is x. So to make use of the result that we just found, we are going to divide each term by the highest power. This will give us 2 over 1 plus 1 over x when you simplify. Now, if you try to substitute infinity, you will get 2 over 1 plus a number over infinity, that's 0. So the answer is 2 over 1, which is equal to 2. Let's have a look at another example, like this one. If we have limit 6x squared plus 3 over 2x squared plus 5 as x approaching negative infinity. As you notice here, the highest power is 2, so I'm going to divide each term by x squared. Let's do that. And when I simplify this, I'm going to get 6 plus 3 over x squared, 2 plus 5 over x squared. Now, if you substitute in negative infinity here, you will get 6 plus 0 over 2 plus 0 also, which means the answer is 6 over 2 only. Okay, that's good. What about this thing? Am I going to keep dividing? What is the key? Is there a shortcut? Actually, have a look at this. What's the answer here? It's 6 over 2. What were the coefficients of the highest power that we have? 6 over 2 also. Does that work all the time? Let's have a look here. What's the answer? It's 2 over 1. What were the coefficients of the highest power here? It's x, so it's 2 over 1. So again, I'm talking about the coefficients of x with highest power. So we can do this example very quickly actually. We have 8x cubed plus 5x squared over 4x cubed minus 8x. So the highest power is x cubed here. So what are the coefficients of x cubed? It's 8 over 4. So immediately the answer will be 8 over 4, which is 2. What about this one? Oh, what's the highest power here? The highest power is 4 actually. So I need the coefficient of x to the power of 4 in both the numerator and denominator. We don't have x to the power of 4 in numerator, so this means that it was actually 0x to the power of 4. So the coefficient of x to the power of 4 here is 0 over 4. So the answer of this will be 0 over 4, which means 0, since 0 divided by a number is 0. Okay, what about this case? 8x to the power of 4 over 4x cubed. Now again, the highest power is x to the power of 4. So here we have 0x to the power of 4. So the coefficients are 8 over 0. So the answer in this case will be 8 over 0. And as I showed in a different video, a number divided by 0 will always be equal to either infinity or negative infinity. So in this case, we have infinity. Actually, this is a very special case, and I'm going to talk about it in details in a separate video. Well, that's it in evaluating limits at infinity. Okay, guys, let's have a look at the first example that we did. It was y equal 2x over x plus 1, and the answer of our limit when x is approaching infinity was 2. Look at this green line here. It was our answer when x approaching 2. What's happening to the graph? The graph is moving beside the horizontal line y equals 2. That's why this line will be called a horizontal asymptote. Well, the second example that we did was 6x squared plus 3 over 2x squared plus 5, and the answer of that was 6 over 2, which is 3. How would that affect the graph? Does it show here? As we said, it should be a horizontal asymptote. So let's try to graph y equals 3. Well, that's perfect. Look at that. The graph is moving beside the horizontal asymptote, y equals 3. So actually, limit at infinity is used to evaluate or to find horizontal asymptotes. And as we said before, functions may have vertical, horizontal, or slant asymptote. I've explained how to find vertical asymptote before, which is when limit f of x as x approaching a certain value approach infinity, while horizontal asymptote when limit f of x as x approach infinity equals a certain value. I'm gonna show you in a different video how to find slant asymptote and some cases of special horizontal asymptotes. So, what are the results that we have so far? As we explained, to find the vertical asymptote, we need to evaluate limit of a function as x approaching a certain value like a, and if the answer is equal to infinity, positive or negative, and if we are approaching a from right or left. If this case happens, then f of x has a vertical asymptote, which will be x equals a. What's the other result? The other result is actually for limits at infinity. So if we are approaching positive or negative infinity for a certain function, and the answer was a value L, then what's the result? This means that f of x has a horizontal asymptote, which is y equals L. These are the main results so far. So for example, if I'm talking about, let's say, f of x equals 2x plus 1 over x minus 1, and I need to graph it. Then the first thing that I would look for is the domain and then the asymptotes. So what is the vertical asymptote? The vertical asymptote is the answer of limit 2x plus 1 over x minus 1. And what did I say the possible values of vertical asymptote before? The possible values are the zeros of denominator. And the 0 here is 1, so I'm gonna make it limit as x approaching 1, and the answer will be 3 over 0, so that's infinity. And as we said, we should check either right or left side. So if I'm checking 1 from the right side, this means the answer is infinity. Is it positive or negative? 1 from the right, so 1.1, for example, minus 1, that's positive value. So I'm gonna approach 3, I'm gonna approach 0 from the right side. So that's a small positive value. So positive 3 over positive number, that's a positive infinity. What does this mean? This means x equals 1 is a vertical asymptote. Now, same thing, we can check for horizontal asymptote as x approach, let's say, positive infinity. Our function is 2x plus 1 over x minus 1. And as I said, in this case, we can immediately depend on the coefficients of x with highest power, which is x to the power of 1 in this case. So the answer will be 2 over 1, which is 2. So our horizontal asymptote in this case will be y equals 2. So such a function will have a vertical asymptote and will also have a horizontal asymptote.